Hello and welcome to the Sweet Chronicles, where we deep dive and level up. Today we'll talk about the DiskLRU cache. If you've ever wondered what it takes to develop a DiskLRU cache, then look no further. Let's outline the functional requirements for a cache. The primary goal is to enhance application performance by reducing latency through local data storage. This comes at the cost of increased memory usage. An LRU cache strategy will help us optimize memory by prioritizing frequently accessed data. To ensure data persistence across application restarts, our cache must be durable. We'll assume data is sourced from a remote server via an API and then stored in the cache. To maintain a familiar API, let's design our cache to resemble a standard map or dictionary data structure. This will allow us to use common operations like get, put, and remove with an expected average time complexity of O of 1. To ensure data integrity in multi-threaded environments, we'll make these operations thread safe. To provide comprehensive control over cache management, we should introduce a configuration object that allows developers to specify the cache size. That will control the maximum cache size, influencing the LRU eviction policy, the amount of persistence for this cache, which will also be configurable. It allows for developers to control how much space that application is allowed to occupy within an application. We'll also set an in-memory cache size, which can be useful for optimizing performance in memory-constrained environments. Now moving on to some non-functional requirements. The first one, we'd want to avoid performance bottlenecks and potential crashes. It's crucial to implement a caching strategy that doesn't load all data into memory at once. For example, in a photo viewer app, caching all images simultaneously could exhaust available memory, leading to application slowdowns or crashes. Our next non-functional requirement would be to prevent excessive storage consumption. We must implement a strict cache size limit. The LRU eviction policy will asynchronously remove older entries from the cache as needed to stay within the specified storage constraints. Now the final non-functional requirement. To ensure data integrity and reliability, the cache must be resilient to crashes. This means that the cache should be able to recover its state and maintain consistency even after unexpected interruptions. To achieve this, we will implement a journaling mechanism. The journaling involves recording a sequence of cache operations, namely writes, reads, and deletes in a log file. This log can be used to replay operations and restore the cache state in case of a crash or unexpected shutdown. Thank you for watching the first episode on the DiskLRU caching. In this episode, we explored the functional and non-functional requirements for our cache. In the next one, we'll delve deeper into the design and implementation for this DiskLRU cache. See you soon.